Within this presentation, we're going to be looking at the following topics: software and licensing, how to submit a hardware issue, the Skyhigh web gateway troubleshooting, there's some subtopics to that one, and the perfect case SR. So, licensing and software can be downloaded from our content and security portal. Additional products are available within our main Trellix website. So if you're looking for Skyhigh Web Gateway or Skyhigh Client Proxy, then you can find both within the Content Security Portal as well as your licenses. You can find your license files here as well. But if you're looking for our other products, like the Content Security Reporter or the Enterprise Product Removal Tools, or pretty much any of our other products, then you'll find those on the actual Trellix main website. The link is just here. You just select the downloads option and you'll be taken through to that portal. Support can assist with some general licensing issues, like helping you find your licenses or the license installation processes. But if you're missing features or products from your licenses, then you should probably get in touch with our licensing@trellix.com email address. Finally, there are some general FAQs on that KB article that's just on the screen there, KB 77816. So if you're looking for some general FAQs regarding licensing or common questions, you can find those posted on that KB article. Okay, for hardware troubleshooting, we actually have a KB article on how to submit hardware issues to support. The KB is just there, KB 89685. You're going to be required to install a script and run that script. We call it the getLogs script, as you can see in brackets here, a hardware log, and some required information. This is pretty much needed for all hardware topics. RAID errors, you'll see these alerts on your dashboard. RAID alerts, disk failing, BBU battery replacement required. Those two are pretty much the top two contenders for hardware issues because they're naturally going to get old over time. So on this KB article, you will find here is the yum install script. So you do need to be able to run these yum commands. If this proxy is behind another proxy, so a next-hop proxy, is a Linux server, so you can of course enter a HTTP proxy first, maybe do a wget to get the script, and then install the script afterwards. So there's a couple of different ways you could download the script manually and just transfer it over to the web gateway manually and then run the script. So there's quite a few ways that you can get it, but the standard way is just to yum install. Yeah, you'll see that you can just run the script by the following command just here. There is an alternative to doing this to the get logs. You can collect the system event logs, but primarily we want the get logs. This is our primary goal. What we also need is this template. If you don't provide the template, then it's just going to delay the hardware replacement because the first thing we're going to do is email you back asking you for this templated information. Of course, there's some things on the template that we're going to be able to collect because it's collected in the log files anyway. So we're going to get the product, the model number, the serial number, the entitlement. So you don't need to worry about that bit too much. But the rest of it, from I would say here to the bottom, is going to mean we are going to need you to provide this with this information. So yeah, that's pretty much the get logs. Once we have both the get logs and the template, there's pretty much no delay in finding the replacement hard drive or getting a new BBU battery getting sent out to you. So do try to get us both at the same time, and it'll avoid any hardware delays. And here's a quick example of running the getlog script. Okay, so here I am already logged into my web gateway. So we will copy the command to install the getlog script. Go ahead and do that, and then just run the command to run As we can see here, it's also going to be outputted to the /opt directory in a file called get logs output. Here you can type in, I don't know, hard drive failing, or D. Ahead and collect all of our information. We have a connection to the server here, so we're just going to the directory. Here we can see the get logs is, so we can transfer that to our normal PC and get that uploaded to us. Be able to investigate your hardware issue. Okay, so next we're going to look at the secure web gateway troubleshooting, the feedback file and generating of the feedback file, rule traces to identify delays or blocks or why something is allowed, TCP dump network tools, so how to trace the traffic in a bit more detail than rule traces, so on the network layer, connection traces, really important topic. Very useful for supporting any kind of problems. The core file, how to essentially whenever you have a memory issue or you high CPU issue or anything that's CPU memory or crashes, basically we're going to want a core dump file for. So how to generate those, auth debugging, and then some common issues to look at. The secure web gateway troubleshooting feedback file. Now, the question may be a simple question. You may be asking how to add a rule which blocks a website based on the following criteria. It could be a more complex issue. Maybe there's a problem with scanning a file. But the feedback file allows us to provide you with a full response. We can tell you how to create a rule to block something, but we can't tell you where to put it in your rule set if we can't see your rule set. We can't tell you why a file is being delayed in being scanned because we can't see the error logs from the anti-malware engine. So a feedback file is pretty much critical to nearly all support topics. So it's best off to provide these pretty much with every ticket, and just to allow us to review the configuration of your web gateway, your policy configuration. And of course it collects all of the error logs, so core error logs, not core error logs, sorry, the anti-malware error logs. It has all of the varlog messages logs in it, so it's really important for you to collect this. You'll notice that there is a tick box here saying pause running Skyhigh web gateway to create a backtrace. Lots of customers like to untick this box, but because it's a belief that it's going to interrupt user traffic, but it won't. So leave the checkbox enabled. It runs as a low priority, the feedback file, so it won't interrupt any user traffic. Of course, there is a slight increase in usage, but very, very minimal. This runs as pretty much low priority. So if you have a very large web gateway, you could be waiting up to 10 minutes for this thing to generate because it's not going to use a lot of system resources to generate the feedback file. But leave the checkbox checked and then just basically hit the create feedback button and that will generate a feedback file for you. Okay, on this slide we have a demo of the feedback file from an SSH terminal. Okay, so you may also sometimes need to be able to generate the feedback file from the command line. For example, if the web gateway is not, the user interface isn't loading, then you can't click the button in the user interface to generate the feedback file. So in order to do that, inside this directory, opt MWG bin, we can find a script called feedback.sh. This is the feedback file that will generate. This is exactly the same as user interface. On this option here, we ask you to always select option 2 unless being stated otherwise, but just stick with 2 and hit enter to continue. This is going to take about a minute or two, so I don't really want to make you sit there and wait, so I will pause and I will resume once the Okay, so the feedback file has been generated, and it does tell you where the feedback file has been saved to, because obviously you can't download it from the user interface, if that's the example I'm using. So here you can see it's stored in the opt MWG log debug feedbacks directory. And check that by... Here we can see the feedback. So you can transfer that over to your main web gateway, to your desktop, and upload that to us. Okay, so moving on to secure web gateways, troubleshooting, rule traces. So rule traces are one of the best forms of troubleshooting to find out why a web page is being blocked for a user. That's pretty much what it's used for. It provides a trace of the user's connection via the proxy, what information the proxy obtained from the client request, i.e. its IP address, the user agent, the host it was requesting, the category for the particular site as well. Now, there are two results on each rule traces. So when you click on a rule trace, you'll see top properties highlighted in red, I believe at the top right hand side screenshot, highlighted in red, and details highlighted in purple. So if we just have a quick look at this screenshot on the top right hand side, top properties will show us main information about the request. So the URL, the client IP, the response code. This is quite a quick view. We know that it's not blocked because we can see the green right arrow, so we know there is no block here, so that's fine. In the screenshot at the bottom right hand side, I just blocked streaming media for everybody on my lab, so you can see the red arrow highlighting that it's blocked, and I've selected the details panel to see why it was blocked. We can see a tick by the criteria for URL categories is in one of the list, and then just underneath that we can see what was evaluated. So the URL.categories it came back as streaming media, and we know because the criteria is true, there's inside that list. So therefore the result was blocked. So that was by design. So rule engine tracing is very powerful. This is why we always request it from support when you're having issues with a particular website. So this website's blocked for this user, but it's allowed for everybody else, or scenarios like this. We would ask for the rule engine traces because obviously there's probably a group missing from that particular user, and that's why the web gateway is blocking it. So it can be a pretty powerful tool to use in troubleshooting any kind of issues with websites. We can see there just the top. I'll show you it in a demo in a minute. One second. And here's the demo I mentioned a moment ago about exporting them. It was included in this demo. Okay, I'll just play this. Okay, and here is the rule engine tracing under troubleshooting, rule engine central. I've already copied in my IP address. You see here this is the drop down for the different proxies. Go to get started. As soon as you hit go, it's going to trace everything from my Firefox browser here through the proxy engine. I like Firefox because you can select a different proxy than what your normal Chrome or your Edge browser does, so it comes in handy if you're just playing. So this is just a quick example. Again, we're going to use the YouTube video. So filter by, you can filter by all of the different types of blocks or allowed or authentication. We're just going to be triggering the block on youtube.com. Block, you can see I've got a bit of a custom template here. It's the more information I can put on a block page, the better for me. Obviously, company or your organization, you have requirements that you'll put here. But this is my YouTube one. So on YouTube, top properties. Again, you can see the quick overview. So YouTube, client IP, user agent, URL host, and we can see here it was blocked by URL filtering. It was blocked on the command connect, so no outgoing request was ever made. The web gateway did not have to reach out to YouTube and then block it. It was blocked between the client and the web gateway immediately. On the details page, we can see the criteria was met for URL categories. So it checked the URL category for YouTube. It came back as streaming media, and streaming media is inside this block list. You can see here, this is the default ones, and I've just added streaming media just here, and for that reason it was blocked. If I wanted to quickly change that, I could just open this list, delete streaming media, okay, save changes, and I could refresh that, and then I would go over to YouTube. I'll stop the rule traces just there. Here you can export. This is the important part because you need to export the visible traces. Don't just export one rule trace if you can help it, because the chances are you're going to miss the one that we actually need. So export visible rule traces, and select your desktop, save it wherever it is you want to save it, and get that up to support. The other reason why we ask for all rule traces is because, say if it was a YouTube, but the block was perhaps on a script or a CSS file, or some other request that YouTube then also made. So that's the reason why we want the full rule traces. And secure web gateway troubleshooting, GTI delays. You'll see here again a screenshot of the rule engine tracing. There's a big arrow there to 12 seconds. That's a pretty long time to be in the rule engine for. So in the example screenshot, you see I've made a HTTP request, and there's a 12-second delay. This is a normal key indicator that GTI requests are being dropped at the firewall, not rejected but dropped. The delay is due to the proxy trying to request the same thing over and over and over again. So it's trying to look up the reputation, the categories in the example it was httpforever.com. So because of those constant retries, it's delaying the user traffic. There's a timeout of about 2 seconds, I believe it is by default. So it's going to try and try and try again. These requests would be hitting the firewall, for example, the corporate firewall. So the firewall team should be able to trace this traffic and try to allow us. You can see here I've posted a KB article for GTI issues, because on this particular KB article we have a script that you can run in order to check the performance for GTI. Essentially, you're coming into, again, this MWG bin directory, and that is the command to run the GTI diagnostics. Support would request this if you ever reported a slowness issue with the web gateway, and then provided rule traces. We would see this, sometimes it's 12, but I think it could also be 6 seconds, 3 times at 2000 milliseconds, normally be 6. But anything static like that, 6, 12, that's appearing on rule engine traces common, then we are naturally going to ask you for that GTI script. But this is something you could also identify. If you notice 6, 12 seconds, just contact the firewall team. Ask them if they've got any blocks coming from the web gateway, and I'm pretty sure they'll be able to let you know that it is indeed being blocked. And I just added the second KB for this KB article here is our IP addresses for global threat intelligence. Smaller fit on the screen. So it will contain all of the IP addresses and such that you need in order to allow GTI through the firewall. So make sure the firewall team have all of our latest IP addresses and network ranges. And secure web gateway troubleshooting, TCP, dump, and network tools. So again, on the troubleshooting option, and we have network tools. And network tools are a set of tools to quickly run some tests without having to SSH to an actual web gateway. The most common being things like ping, NSLookup, traceroute, and HA-stats. HA-stats is only really applicable if the web gateway is deployed as a HA proxy. As you can see, the top right-hand screenshot, mine is deployed as a HA proxy. And I type in the command parameter all and click on HA-stats. And you can see here the output is that this is the active director, and the scanning node is also the same web gateway. You can see I do have two web gateways, but one of them is not configured in HA. I just have two, but only one's configured in HA. If the other one was also configured in HA, you would see the 192.168.2.59 also listed under there as well. So it's a quick way just to make sure that the HA proxy is working okay. Ping, NSLookup, traceroute will be covered by a quick demo in a moment. Then also we have packet tracing. Packet tracing is another troubleshooting thing that we're going to use. We'll often ask you for a TCP dump, but most of the times we'll actually give you the command to actually run. We can't always give you the client IP address. As you can see here, the host is a local IP address, so that command that you see at the bottom right hand side screenshot, that's only going to trace traffic between a client and the proxy. It's not going to trace traffic between the proxy and a destination because it's filtered only to be the host of the client. So most of the times we will try to give you the appropriate command, but some of this stuff you may need to also figure out as well. I'll give you some examples in a moment on how to figure out these commands in just a moment. On the next slide, we have some explanations on what these commands mean. So generally, they're all the ones that we provide you. They're always going to be -npi any. Again, don't convert host ports, no promiscuous mode, and all interfaces. The host is then going to be something like www.mcafee.com, or some of them is just sometimes mcafee.com, or host 10, 11, 12, 13. So if you were to add host and then a destination, or the host as a local client, that means the TCP dump is going to capture client to web gateway and then also web gateway to destination. You could tag a port on the end as well. So if you wanted to capture DNS as well, well, on the slide it's 445 for authentication, but also port 53 would also capture your DNS. There is sometimes the need to capture a rolling TCP dump, but you need to do this by the CLI. You can't do this on the user interface. Rolling TCP dumps are for those issues where you just can't capture it in a TCP dump because it's happening randomly or not at a specific time. So what we want to do is you want to create a rolling TCP dump, say over 5 or 10 files of 200 meg each, so you're going to use maybe a gig of hard drive space, but it's going to keep overriding those files. And as soon as you notice the issue, you can stop the rolling TCP dump, and hopefully the issue is going to be captured in one of those ones that's already saved. So we'll have a quick look at different TCP dump command line parameters that we can use in the next slide. So this is the quick demo, just showing a very basic quick look at TCP dump and the network tools in the user interface. And we move on to the CLI a little bit in case you want to do a TCP dump from there. Okay, so I came over to troubleshooting and network tools, and here we can start quickly with my firewall. And I'm looking at finish, but as you can see, that works fine. NSLookup, again, these are all pretty standard commands. One of my Windows servers as well. Oh, we can run HA stats as well as soon as it finishes. And HA stats, again, HA stats is pretty important when you're running in HA mode. It tells me this is the active director, and it's also a scanner, so it's also handling traffic. And this is on .gateway. I do have a second web gateway, but that's not a part of HA. It's just part of my cluster. Packet tracing. So packet tracing is a little bit complicated because of all of the many commands that we can use. So we'll just have a look at a couple of the So the first one we'll look at is this one here. So capture everything. This is probably probably not the best command to use in production because the TCP dump is going to hit max size. There's not really ever a need to do this unless you're working in a lab. Another one is between, just going to be looking at this half because this part here is always going to stay the same. So this is between the client, that client IP address, and the web gateway. So it's going to log everything. It's really restricted. This one here is going to log everything between the client and the web gateway, or the web gateway and that destination. Or host trellix.com. Maybe we want to add DNS on the end, so we're just going to tack on all port 53. Maybe we're investigating an authentication issue. In that case, we're going to use something like this. So we want the communication between the client and the web gateway to anything on port 445 or port 53. You can, because of the versatility, because TCP dump is quite versatile, it's essentially the same, pretty much using the same commands as if you were to look up TCP dump commands. So if you were to use this command here on the user interface, then we're just looking at this host here. We can't run this on here because it's on terminal. But if we wanted to replicate that on the terminal, all we have to do is start the command with TCP dump, and obviously tell it that it has to save the file to somewhere. Otherwise, it will just list you all of the packets. It will stream the packets on the screen, but you won't actually save it to a file. Unfortunately, I don't even know if this is going to create an empty file. Oh, yes, it did. 0 packets, but it captured the empty file and it saved it as this name here. So if you're looking online for different types of TCP commands, then you may not be able to use them in the user interface because they're probably quite specific to the TCP dump commands. But if you take out this middle section here, you could then pop that into here. So you don't need to call TCP dump, and you don't need to tell it to save it to a file because the user interface is going to do that for you. But if you're on the user interface, then you need to call the TCP dump command, and you need to tell it to write the output to a file. And of course, once you've got your TCP dump written as a file, if you want to have a look at it yourself, then the screenshot on the right gives you a quick overview of what Wireshark looks like. Once you've opened up the file that you've downloaded from the web gateway or the file that you've transferred from the terminal, there's a few helpful filters here. If you're looking for a particular HTTP request method, whether that's get, post, head, then you can use http.request.method equals get. If you're looking for a URL search, or the DNS one's quite popular. So a DNS request with no response, that's a pretty much indication that there's an issue with DNS. Or if you just want to have a look at a specific protocol, in that filter section that's highlighted as number 1, you can just pop in there something like DNS, and then it will just filter you all of the DNS requests. If you pop in the HTTP, it's going to filter down to all of the HTTP requests. Wireshark's a pretty large, powerful debugging tool. So it could be, if you were looking into this, then it'd be pretty much better to check out the Wireshark documentations, because it's a pretty powerful tool. Okay, so secure web gateway troubleshooting, connection traces. Connection traces and web gateway allow for you or support to review HTTPS connections in the view of a HTTP connection. Essentially, everything HTTPS is encrypted. It can't really be read. Everything HTTP is clear text. The caveat here is that SSL scanning needs to be enabled, because if the request isn't going through the SSL scanner, then web gateway is not decoding that traffic, so we can't read it as clear text using the connection traces. So if you've had an issue with a particular website or a web application, and you bypassed it from the SSL scanner and found that resolved the problem, and then contacted support, you're going to have to reproduce the problem for us. So that means removing that bypass, enable the connection tracing, reproduce the problem, and then put your bypass back in place. The connection traces can be enabled from configuration troubleshooting connection traces. It's one of those troubleshooting options where you do restrict it to an IP address. Do not ever leave it without an IP address. Always restrict to an IP address. You'll run into hard disk problems otherwise. On the screen is an example of what connection traces look like. You can see on the right-hand side of the screen, 2 connection traces open. You will also notice that for each request, there's always 2 files. There's one that ends in a C and one that ends in an S, but the file name at the beginning is the same. This is because the C represents the connection from the client to the web gateway, and the S represents the web gateway to the destination. Within this list of files, under troubleshooting connection traces, you will also find a SSL underscore keys.txt. This file is pretty important because if you also had a TCP dump running at the same time, this allows you or us to decrypt the Wireshark capture, the TCP dump, so we can easily see and use Wireshark's filtering capabilities to find the connection and see the connection as we would in a clear text. But in order to do that, the order of enabling the troubleshooting options has to be start the TCP dump, start the connection traces, reproduce the problem, and then you can just stop them in any order you want. That way we are able to use the SSL keys from the connection traces to decode the traffic that we see in the Wireshark. So some takeaways regarding connection traces. If you see what looks like junk, if you ever open up a connection trace before sending it to support, and you see these 0x00, 0x12, 0x04, don't worry, that's still valid. It's just a HTTP2 connection. From our side, we have a decoder, so we'll just run that through a decoder to see what that looks like. Connection traces will trace from the client in the C file name, and from the proxy to the destination in the S file. From support, we would want the TCP dump started first and then connection traces enabled. So then we can decode the TCP streams. Things like this help speed up the resolution to an issue. Will often be requested by support for issues with websites, web applications, whenever you say it works when we disable the SSL scanner. Issues like that is when we're definitely going to be asking for this. And I thought I'd just share quickly how to actually decode the TCP dump using those SSL keys. So if you were to save the file as SSL keys.txt, open up Wireshark, go to Editor, Edit Preferences, and on the left-hand side there find TLS, and then under Pre-Master Secret Log file name, just browse for that file. Then when you follow these connections, you'll see in the middle screenshot there everything's encrypted, and you can't really see much, but then on the right-hand side one, that's everything decoded, and you can see it. I mean, it looks like HTTP. So yeah, that's connection traces. Secure web gateway troubleshooting. Core dump. High CPU, high memory, suspected memory leak, crashes of the services or crashes of the server. For crashes of the services, so allow the web gateway to automatically enable these core generation files. Under configuration, troubleshooting, it's highlighted just there in yellow. Enable core file generation. So that will allow the web gateway to automatically generate these core files every time a service crashes or the server crashes. It just helps with troubleshooting a little bit further. These files are big. They can range from 2 gig up to 30 gig, depending on web gateway usage and size of the actual web gateway itself. If you need to manually trigger a core dump, this can be done in a couple of different ways, but I'll stick to this one because this is like the catch-all. You need to do it during the issue. If you're contacting support with high CPU, we've reviewed all of the log files. We can't find anything specifically wrong. Then we're going to ask you for this core dump, and it's going to dump the threads, so we can see exactly what's going on with each thread, and we can see what's being hung and causing this high CPU usage or memory utilization. So we'll not often, but we would then reply to you saying, okay, we need a core dump. The core dump is evaluated by our engineering team, and these are the steps to produce that core file. I provided a quick demo here, so I'll just play that to just show you the steps of generating the core file. Okay, so I'm already logged into my web gateway, so I'm just going to copy the commands in to generate this core file. Directories, generate the core. This will probably take a lot longer, but I'm running on a lab machine. Should be fairly quick. The SWG services are still running. Yep. And also check from the user interface if the core file was generated from log files, debug, cores. It was generated 2.2 GB. Okay, looking at our secure web gateway troubleshooting authentication. Authentication debug logging and secure net logon. So again, troubleshooting is under configuration, troubleshooting. And again, here you can restrict tracing to just one IP address. Highly recommended to restrict that, because otherwise this debug log will get extremely large extremely quickly, and you could run into, again, the issue of filling your disk. So the log file would then be located under troubleshooting log files debug MWG core _ auth.debug log. We can have a look at some of the examples or reasons why authentication is not working here. So in this authentication debug log, by the way, this is also included in the feedback file, but if it's done afterwards, then we would tell you to enable the auth debug log and then maybe just provide the single file instead of the whole feedback file again. So on the left-hand side, we've got a couple of examples. These are pretty simple ones, but I can only reproduce a couple of issues using the lab. So error from DC returned, no such user. I entered in user 3. I already knew that user didn't exist, so that was the expected output. User login with misspelled or bad password. Here are the error IDs. X0XC00006A. That's what the DC returned. And it came back as status wrong password. The next one was user logon to account disabled by administrator. Yeah, I disabled it in AD. And again, it hit default case wrong password. These texts match, but the code does not. This code is 0xC00072. And so it just repeated that same error code. No message found RPC. So this one didn't really record that it was user account disabled. It gave us an error message, but it didn't say this user account is disabled. It just gave us a default case wrong password, and then gave us a error code. These error codes can be checked from Microsoft. I've got a list actually on the next slide. I took it from a Microsoft one of their references, but here we can see that 7.2 is user login to account disabled by administrator. And what was the other one? The other one was 6A. 6A here. 6A, it's up here. User login with misspelled or bad password. So yeah, those two error codes matched what the Microsoft documentation says. This is what the auth debug log looks like. It can look like chaos, but essentially these are the things we're looking for. We're looking for the unknown errors from DC, because that's pretty much going to tell us the reason why the authentication was declined. Now remember, it's not the web gateway that's declining or saying no to the user. The web gateway is making a request to AD or DC, and it's that response that's saying no. So I just wanted to make sure that part there is clear. We're only passing on the details that were provided from a client. So in conjunction with authentication debug logs, it's pretty common for us now to ask for these net logon logs. Because web gateway communicates via port 445 with secure. This net logon secure, because of the CVE that Microsoft had last year, they pretty much enforced it. Net logon secure or secure net logon. They pretty much enforce this now on all Active Directories. So all we now see is blob data. Before, we used to actually see the error code being passed back in the TCP dump. We could see quite a lot in the TCP dump, but now we just see blob data. So net logon logs will record the request and the response, but this is done on the Windows server itself. I've included the URL here. Include the URL here to how to enable this, but on the next slide also is my example from my Active Directory server. Essentially, we log on to AD. We enable this using a elevated command prompt. We enable it. We go to C drive Windows debug, and here again you will find the requests that Windows Server logs. I actually find there's a lot more data logged here than the other one, than our authentication debug log. Like I can see here, it was homelab/user3. Homelab is my domain. User3 is the fake user that doesn't actually exist. It says it came from MWG main, and which is the host name for my web gateway, and it returned this code. And then further down here, you can see I entered a valid user, but I disabled the account, so it was never actually going to authenticate. So again, logs can be found, C drive, Windows debug. It's pretty common now for us to actually request this log, so do be prepared for when our support teams do say, can we have the net log on debug logs from AD. Secure web gateway, troubleshooting common issues. So common issue, disk space. Disk being filled up by log files, debug files, connection traces, rule traces, core files, temp files, syslog, whatever the cause is. You'll see the alerts on the dashboard, file system usage on /opt exceed selected limit. As soon as you see this, you should start engaging immediately to find out what's the cause, where are the files. I would start with where are the files and delete them as soon as possible, because it will result in not being able to log into the user interface anymore. You won't, and if you could, then you wouldn't be able to save changes. MWG services will stop. They'll be running, but not correctly, or they'll start to fail to start. They'll stop, but then they won't start, and eventually users won't be able to actually use the proxy as it's designed. Dashboard alarms, they are printed on the dashboard, as you can see here, /opt exceeded, /var exceeded. The first thing you should be doing is try to determine where are the files. What are the files being filled up? Because if it's in /var log or /opt mwg log debug connection tracing, then that's going to help you determine on what the cause of the problem is. So if you notice that the connection tracing directory is 10 gig, it's probably because connection traces have been left on the web gateway. So once you've determined the location, again, for example, varlog messages, it's probably a high probability that access logs are being written to the varlog messages file because rsyslog wasn't configured correctly or incorrectly. It's quite a common scenario. And then if connection traces directory, then connection traces have been left enabled. You can use this command here, find/opt. I can't read the command out to you, but you can see it on the slide. You can run that command quickly. And if you're contacting support, maybe export the output of that command to a text file. But if you're quite familiar with Linux, I would probably recommend you just to start having a look. If you have like Bitwise or something where you can browse the files, have a look around in the directory. If it's /opt, then it's going to be in the /opt directory. So you can run your how big is this directory commands, figure out where those files are, because you want to get those files removed as soon as possible. Remember where you had those files. So if you found them in the rule engine tracing, or if you found them in the /var log messages, remember where you saw them. Maybe save one of those files. Have a look at it. Is this access logs? If yes, okay, I'll let support know about that. So once you've deleted all of the files, because that's the main priority, not to fill up the disk, generate a feedback file because you want to have free space, and let support know what files were where and roughly what they contained. Because if it's in varlog messages, and you say, I think it was access logs that were being logged, then we can immediately take your feedback file, we can check your rsyslog config, and we can see if you've edited the commands there to not write to varlog messages. And if so, and if that mistake was made, then we could let you know how to quickly correct that and fix it so it won't happen again. We also have dashboard, charts and tables. You can review these for general information. You can have a look at DNS responses, request responses. You'll be able to see delays. And you'll be able to see all of this type of information on the charts and tables. We also have common issues with cluster configurations. Most of the common problems are synchronization issues, login failures, failures to save changes. When you see these types of things, it's normally going to be a pop-up Java pop-up message saying it's unable to save changes because blah, blah, blah. It can be quite common that the time syncs between the proxies aren't in order, so you need to make sure those everything has NTP enabled. You can see in this screenshot just up here these groups. Oh, sorry, these groups here. So we've got a runtime group, an update group, and a network group. We need to make sure that everything has a line of communication. And if you are running more than 10 proxies in a cluster, you need to think about the design of these things, because they're going to be a mesh. They're all going to want to talk to each other. Is that what you want? Do you want, maybe if out of these 10 clustered appliances, you've got 5 in Germany, 5 in France, maybe the France ones should just speak to the France ones and the German should just speak to the German ones, and then maybe pick one of the two and have those in a group so that they can talk to each other, and then everything in France will flow up to its top proxy to get all of its changes, and the same on the German side, and then the German and the France are able to talk to each other. So common issues with clustered proxies. Yeah, so what I was mentioning a moment ago about trying to split up the cluster slightly, I think this screenshot here should clear this up a little bit more. I was talking about France and Germany and and whatnot, but this is the perfect screenshot that kind of summarizes it. Tokyo, New York, and the 2 transit nodes. So Tokyo number 2 runtime update network, all set to Tokyo. Tokyo number 1, Tokyo, 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 but also a transit on New York, New York 1, New York, New York, New York, and transit. So that means that Tokyo 1 can talk to New York 1. Tokyo 2 would talk to Tokyo 1. It wouldn't, Tokyo 2 wouldn't need to talk to New York 1 or New York 2. So it will keep the cluster in a more bring better performance. If you ever click Save Changes on your web gateways and there's that 10-15 second delay, then that's the time when you should start to think, do I need to create these different runtime updated network groups? Because if you're waiting 20 seconds every time you're saving changes, then something at some point is also going to happen and start causing network delays with synchronizations between the proxies. Then they're going to stop talking to each other. It could also happen that longer delays in all kinds of aspects of when the cluster needs to talk to each other. So it's a very good idea to start thinking about separating them up into these different transit groups when you hit that Save Changes button and it's taken 10, 20, 30 seconds in order to actually complete the Save Changes function. And then finally, of course, we also have the version check. Version check can be problematic when you're trying to upgrade your cluster. The web gateways, they have a tolerance, so those minor versions, 10.2.5 to 10.2.6, probably not going to be much of a problem. But if you start trying to run versions 9 with version 10, you are going to have a problem with version checking. So if you have to, if there is no other option, because normally we would recommend to build out the cluster as you upgrade them, just have like a no policy change in effect, remove a proxy, upgrade it, remove another proxy, upgrade it, and join it to that new one that you've just upgraded. But if you don't want to do that and you have no other option, then you can disable this version checking of other nodes. I would never recommend doing this, and if you were to do it, it would be within the upgrade window where you're upgrading all appliances all on the same day, and you're not going to leave it for another week or another month before you start to upgrade the other ones. Unfortunately, we really don't recommend running different versions of the web gateway in the cluster. Okay, and that brings us to the perfect service request. It probably doesn't exist, but support can always wish. Detailed description, date and time of the issue, expectation versus given behavior. So detailed description, we're not looking for the word slow. You can use the word slow, of course, but what is slow? Slow isn't a measurement of time. So my expectation of a DNS lookup is 20 milliseconds. That's how fast I want a DNS request to be looked up. But different areas of the world, that could be slightly different. So slow isn't a statistical number we can use. So if a website is taking a long time, count how many seconds roughly is that taking to load this particular site. So you say it takes 20 seconds to load this site, but we're expecting it to load within 2 seconds. Then that's something we can use, and we can filter the data for that. A feedback file is always important, pretty much in every ticket, unless it's a theoretical question, I suppose. I mean, even if you say to us, how can I block this URL? Well, okay, URL. Is that with a path? Because if that's with a path, that means you need to have SSL scanning enabled. Do you have SSL scanner enabled? I don't know. So I don't know where you're going to put this rule. So feedback file also for, a file's not being scanned or a file's taken too long to be scanned. Those types of errors will be logged in error messages, in error logs. So it's good for us to have that feedback on pretty much all service tickets. And no, we don't we can't use the same feedback file from previous tickets because we obviously delete them when we no longer need them. So unfortunately, it is one of those things that you would have to provide on most tickets. A TCP dump client plus MWG. We do get a lot of TCP dumps that are filtered by the client, but the issue is between MWG and the destination. Again, it comes back to those discussion on the slides where we're creating the filters between client, web gateway, and destination. We would also ask you to provide that client IP and the URL so that we can quickly filter. Otherwise, we have to try to figure that out from ourselves, which is mostly possible when we have the rule traces. But if the rule traces contain other URLs, then it's not so easy for us to know which ones you're talking about. So always let us know the client IP and the URL that you're having a problem with. Connection traces should always be provided when there's a problem, when you're reporting a problem with a website or a web application. Same with rule traces and the TCP dump, always when there's a problem with a web application. Our initial response would be a fairly long email back asking you for this debug data. So if you provide that on first hand, it saves that email having to be sent, and we can immediately start to investigate. Details on infrastructure. Okay, in brackets, complex setup, because we know we're dealing with enterprise, so we know that we're dealing with the proxy. You've got switches, you've got other security, IPS, IDS. There's other routers, and of course there's the main firewall. But if we're starting to go into a really complex issue, then sometimes it's nice to know that there's an F5 here and there's an F5 there, and we're using this VLAN here. And when it starts to get really complex, then it's nice to actually have the not an in-depth network diagram, but a quick sheet of paper. I've had to request it a couple of times for different tickets, but it's not too often we need to know the full details of an infrastructure. But I think that as you go through a service ticket, that could be expected at some point. I wouldn't say it's needed for every ticket at all. And of course, the steps already performed, because you don't really want us to start saying you steps that you've already performed and you've already tested, because that can be frustrating for customers. So if you've already tested this and you've already bypassed it, you've already disabled HTTP2, then let us know, because that helps us with troubleshooting also. Like if you have a problem with a particular site loading, but it works when you disable HTTP2, that's perfect. We know then that there is a problem with HTTP2 with that particular site, with the proxy. So any troubleshooting steps you provided, always provide that in the service ticket. And that brings us to the end. So thank you for listening to me. Sometimes I waffle a little bit. I do apologize for that. And yeah, thank you very much for your time.